Okay, so we're going to watch this first video. There's no good sound. Sorry. So just watch this one. And this is the seconds timer in the bottom left corner. All right. Now it's going to go in half speed, so slower motion. So this time I want you to try and draw out what's happening on the graph. And when I say that, you want to use your little draw button if you're using Cami here. And I want you to draw how he's going through with his press ups. Is that what they're called? I don't know. I don't work out. It's not a thing I do. Okay, so give your best shot. I'm very interested to see. Oh, bench pressing. Okay. Yeah, I don't know. Here we go. All right. So now they're going to show you the answer. I'm very curious how close we got individually. How'd we do? Anybody get close? That's okay. We're going to do another one. Okay. So the next one's called height off the ground. So it's talking about this guy's waist. So think about how far his waist is off the ground. That's what we're focusing on here. Okay. So remember the first one, just watch what's happening. When it does slow-mo, that's where I want you to try and draw your graph. And then we're going to compare and see how well we did. Just so you guys know, I did very, very awful when I did these. So do not feel bad by any means. It was just, I did so bad. So we're focusing on how high his waist is off the ground. All right, now I want you to draw your graph. All right, let's see how we did. All right, did anybody do pretty close? Okay. All right, so now we're going to actually talk about the things that we're going to be learning today. And so we have a distance from a bench. We're going to talk about increasing, decreasing, and constant. Now, the biggest thing with graphs is I have this written in red here, and if you want to write it, you can. But you read graphs from left to right. Okay, we read graphs from left to right like a book. You don't just look at them and see all this information. You actually read from left to right, especially if you choose to go into finance. Now, let's talk about what increasing, decreasing, and constant is. So if I say the graph is increasing, do you think your graph is going up, going down, or staying flat? Yeah, going up. So I'm going to write that little definition here. So that means it goes up, and I'm going to yell up at myself. What about decreasing? What's going to happen in your graph for decreasing? Yep, it's going to go down. Are you going to let me type, computer? Thank you. So it goes down. And then if it's constant, this is a new kind of fancy term. But what's that? Yeah, it stays the same. I believe the word I used was it stays flat. Stays flat, right? So when we write about increasing, decreasing, and constant, and this is a love note for yourself. If you want to use it, great. I recommend that you use it. But we use the x-axis to write where the graph increases, decreases, and is constant. Okay. When I say x-axis, does that mean the up-down line, or does that mean the left-right line? Like, does it talk about the distance here, the distance, or the time? Sorry. Yeah, we're talking about time, right? We focus on this area here, this left, right, the x-axis, that's what it's called. We focus on that to write where something is increasing, decreasing, constant. Okay. Now, before we write all the mathy stuff out, we're just going to do some highlighting here. Okay. So I'm going to highlight in different colors. So increasing, I'm going to highlight in blue. Decreasing, I'm going to highlight in purple. And constant, I'm going to highlight in green. Now, when I look at this graph, is there any like flat constant sections happening here? And I'm talking about straight up flat. Not even a little bit, right? Because even right here, it's not flat. It kind of is like a little bit of a hill. So it will not be considered a constant. So there's no constant sections here. All right, so we're going to go through and we're going to highlight where it's decreasing first. And the reason I'm going to highlight where it's decreasing first is the first part of my graph. He took that barbell down, right? So it was decreasing. Okay, so from here, oh my goodness. I don't know how you guys don't get more frustrated with these computers. So from here to here, it's decreasing. I'm highlighting where it's decreasing at. So from 0 seconds to 1 second, it's decreasing. When's the next time it starts decreasing? At 2, right? At 2 seconds right here, this is where it starts decreasing, and it decreases all the way until 4 seconds. What's the next time we see it start decreasing again? Nope, not at 6, at 5. Yep, so it starts decreasing at 5, and it looks like it goes until about, we'll say 6, I don't know, something. When's the next time we see it decreasing? Nope, 8's right here. I would call this 7.5. and it decreases to about right here. Now, the next time it decreases, it's not as obvious. I don't know why I said it like that. It's not as obvious, right? So see how this little hill, it goes up just a smidge and then goes back down? So I'm going to say it starts decreasing about right here and then stops again. And that's all the decreasing that we will see, right? Because from there, he slowly lifts that bench press back up. Now we're going to highlight all the increasing sections, which is basically everything else that isn't highlighted, right? Because there were no constants. Start from here to here. So I'm just going to go through and highlight those because there were no constant sections. Oh, that was bad. Let's not make it super awful, Miss Rowolf. I do not know how you guys don't get more frustrated with this stuff. Or do you? And then I just don't know. Okay, so we have everything highlighted out. I think this is easier for when we write out our intervals. Okay, so we're going to write it two different ways. We're going to write it using words, and then we're going to write it using interval notations. So I'm going to focus on increasing stuff first. So what is the time highlighted in blue that it first increases? From what time to what time? Well, we see it increases from 1 second to 2 seconds. So I'm going to write that out. 1 to 2. That's it. That's the wordy word version. Anybody want to give a guess on how it moves the second time? From what time to what time does it increase again? Perfect. 4 to 5. What about the next bit? 6 to 7.5. You're close. That's what I said. I said 7.5. That was my guess of where that happened at. The next one here, I'm going to say this kind of happens at like 9.25 seconds, right? It's not exactly halfway, but it's a little bit less. To, I don't know. Would you guys say this is also like 10.25? I don't know. Sure, to 10.25. And then when's the last bit here? When is it increasing? From what time to what time in blue? Yeah, like 11 to 15. So now, right, this is like using not math notation, which is, helps our brains. I'm just going to space it out a little bit here. Now we're going to do something called interval notation, right? This is the mathy way to do this. So when I write this in interval notation, for 1 to 2, I write it parentheses, 1, comma, 2, close parentheses. That's my interval notation for this first one. 1 to 2, 1, comma, 2. So how do you guys think we're going to write 4 to 5? Perfect. What about 6 to 7.5? Perfect. And what about the next one? 9.25 to 10.25. Brilliant. And then the last one would be 11, comma, 15. Did I break anybody's soul with this interval notation? first I did. But is it better now? Okay. All right. Now let's talk about our decreasing stuff. Our decreasing stuff. All right. So let's use our words first. Let's use our wordy words first. What's our first time frame that it is decreasing? From what second to what second? The first highlighted purple section. Well, that's blue, and that's increasing. I'm talking about purple. It's okay. The first one right here is from 0 to 1. And then like Jeremiah said, it's from 2 to 4. That's the next section that's decreasing. What's the next section right here that I have? The third purple highlighted section here. From perfection, 5 to 6. And then my fourth purple section right here is 7.5 to, oh geez, what did we say? There you go, 9.25. And then my last little purple section, the very skinny little guy here. Yep. I think we said 0.25, but that's okay. Whatever you choose in your homework is fine. 10.25, and then you said to 11. So we wrote this all out in wordy wordness. Now I'd like us to write this out in interval notation. So how would we write the interval notation for 0 to 1? Parentheses. Perfect. 0, comma, 1. The next one we have parentheses 2, comma, 4. Then we have parentheses 5, comma, how do you say that? 6. Oh man, you guys. Then we have 7.5 to 9.25. So we write that as parentheses 7.5, comma, 9.25. Oof. Last one. Somebody tell me how to write the last one. Oh, beautiful. Beautiful. Okay, so the next thing we're going to talk about, dun, 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 is called maximums and minimums. Now, when we write, I forgot to erase this, but when we write maximum and minimums, we write them as ordered pairs, right? We know this. We learned this, I believe, last year, 7th grade. I don't remember. I'm old. I don't remember when we should have learned this. But when I say a maximum point, somebody tell me, how would you describe a maximum point? Describe it as a high point, a low point, a medium point. How would you describe a maximum point? Yep, it's a high point. And I'm going to yell that, and I'm sorry I just kind of yelled in your guys' earballs. It's a high point. So what would we describe a minimum point then? A low point, right? Low points. Low, 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 low. Drop it low. Low point. Okay. So before we write these guys all out, what we're going to do is we're going to go through and just figure out where our max points happen at and where our low points happen at. Now, I'm going to do maximums in green and minimum points in blue because last time I did them in Christmas colors and that made me sad. I do not like the colors red and green together. Okay, so let's talk about maximum points. So we're looking for where we see a peak of a mountain. So see how my fingertips kind of come together, we're looking for peaks here. So the first time we see like a peak happening is at 0 seconds. Right here. Come on. Oh, it's because it's super tiny. So right here. What's the next time we see kind of a peak occurring time-wise? At 2 seconds. What's the next time we see a peak kind of occur? 5. Now the next one's kind of hard, but what's the next time we see like a peak occur? Well, 8's right here. So I would say more like 7.5, right? The next peak that occurs is very difficult to see. But again, it's that, see how we have this little Humpty Dumpty happening here? I'm going to say our peak is about right here, okay? Now, peaks happen when you go from increasing to decreasing. That's another way you can think about it. It goes from increasing to decreasing. And then we have one more peak. Does anybody see where our last peak is at? Because it's still going up. Ooh, at 15. I think you said it, Jeremiah. At 15. So these are all of our peaks, all of our maxes. Now let's find all of our mins. What's the first time we see a min? What second? It's where we see like a bottom of a V. What was that, Imani? At 1. At 1. What's the next time we see like the bottom of a V? Faux. Faux for show. What's the next time we see the bottom of a V? Right here? I'm leaning more towards like 6. I'm going to say more like 6. Yep. What's the next time we see kind of like a bottom occur? Yeah, like a 9. I'm going to say like that's like a 9.25. And once we have one more, can you see it? 11. So here's all of our maximums, our minimums, tops of a mountains, bottoms of a V. So now we have to write them as ordered pairs. Okay, so let's start with our max points. If my computer is going to let me type here. All right. So this first ordered pair, this first point, remember, we write it as the x value first, the y value second. In this case, it's the time and then the distance. So at this time, it's 0 seconds and 3 feet. So when I write that, it's 0, 3. Please do not confuse writing points with writing increasing and decreasing intervals, please. They look exactly the same, but they'll mean different things depending on what's being asked of you. So be careful. So this is a point, 0, 3. How would we write this next point here that I'm pointing at? Time first and then its height. So anybody want to give a guess? 2, 3. So parentheses 2, 3. Perfect. What's the next? How would we write the next point here? Excuse me. We would write it as 5, 3, right? It happens at 5 seconds and it's still 3 feet high. What about our fourth point here? Are you guys just zooming ahead of me? 7.5, 3, right? 7.5 seconds. It's going 3 feet up. What about this one, right? So we said in our increasing, decreasing that the time here was 10.25 seconds. But what's the height? That's not 3 feet. It's like 1, so it's a little bit above 1.5. What would you say that's at? Yeah, let's go with 1.6. I'm cool with that. That's what I wrote in my little notes here. And what's our last max point? What's our last max point? Perfection, 15, 3. All right. Let's talk about the mins. The mins are going to be a little bit easier, in my personal opinion, because they're all pretty much in the same kind of height location. So what's our first minimum? How would we write our first minimum here? Perfect. Perfect. What about our second minimum? Perfect. Perfect. What about our third minimum? Look at Jada rocking it. Rocking it. What about this fourth one here? That's not 9. But Beautiful. Beautiful. Perfect. Perfect. Last one. Perfect. Perfect. All right. You do not then have to do the height of the waist off the ground unless you should we do extra credit points for this? If you want to do this? All right. Let's do So if it's extra credit, it has to be all correct. So I'll give 1, 2, 3, 4, 5 extra credit points for each little section here. Okay? And it has to be correct. If it ain't correct, you don't get the extra credit points. Is that fair? Sorry, I kind of yelled that. Okay. All right. So let's do some finals review. Let's do some recursive formulas. Okay. Do you guys want to do the left side or do you guys want to do the right side? Let's do the right side because I did the left side last class. Okay. Does anybody remember what a recursive formula looks like? It's okay. Be honest. Not even a little bit. Think so? All right. So if you're typing this out, this is what I'm going to recommend you do. Use your text box. Okay. And then see how there's like a little FX thing here and you hover over it, says formula. Click on that guy. So the recursive formula in function notation, which means you use F's, is f of n is equal to f of n minus 1 and then something, right? That something changes with each table. But what I wrote here, f of n equals f of n minus 1, that don't change. That remains the same no matter what. And then with recursive formulas, they had them pesky start values. So you had f of something equals something. Very specific, I know. So that's the function notation. Does anybody remember what the other notation was called? So the other notation was called subscript. Okay? So there was 2 recursive formula notations, function notation with F, subscript notation with subscripts. So we used A sub n is equal to A sub n minus 1 something. Very specific, that something. I'm going to space this out so it looks a little prettier. And it also has a start value. So A sub something equals something. So once again, all those blank spaces change with your table, whatever information you're given on your table. But everything I have typed out that doesn't change. That's the same no matter what. Now I'm going to do something crazy fancy here, and I'm going to copy this. Right? I'm going to try to copy this. Copy, paste. I sure am, my dear. I sure am. So let me ask you this. When we look at this table here, how do we get from 3 to 6? That's the same as getting from 6 to 12. That's the same as getting from 12 to 24. By 3? By 2. By 2. We're multiplying by 2 here. So let me see if I can write this out. Multiply by 2. Multiply by 2. And these are the same values. So once again, we're multiplying by 2. That didn't change here. Now this multiplying by 2 in my recursive formula goes after my f of n minus 1. So it's multiplied by 2. Same with my subscript notation. It's still being multiplied by 2. So everywhere after the f of n minus 1, it's being multiplied by 2. Because basically what your subscript notation is saying to you is the next number, f of n, the next number, is equal to your current number times 2. So this is saying my next number, 6, is equal to 3 times 2. That's what it's saying. Now, we have to look at our start value. Do we remember where we look for our start value in a table? Yeah, at the 0. So these first two terms here, or I'm sorry, these first two numbers, 0 and 3. So my start value to write in function notation is going to be f of 0 is equal to 3. When I write it in subscript notation, it's going to be a sub 0 is equal to 3. Wow, that looks kind of ridiculous with that tiny a. Okay. But what is different with my start value for this side, for the right side of the right side? Yeah, it starts with 1, right? We have 1, 3. So my start value in function notation would be what? It would be f of 1 is equal to 3. And then a sub 1 is equal to 3. Questions? Panic? Concern? Please ask questions, right? This is some review. No questions? Okay. You got one? I'm happy to answer. Okay. May I wait? Oh, wait. I'll wait. I'll give you guys a couple seconds. You guys are a little bit faster than the last class to copy this down. So again, everything that is typed out and looks really nice here, that will never change, no matter what table you use. But the stuff written in colors in my very bad Chromebook handwriting, that changes depending on your table. Okay. Is it okay if I go down? Okay. So now what I want us to do is fill out a table using the recursive formula. So last class I started with this side, so I'm going to focus on the left side this time. So first we have to figure out our start value. What in this f of n is equal to f of n minus 1 minus 3 f of 2 is equal to 10? Which part of this tells me my start value, where I begin at? Anybody? Nope. This part right here. This tells me my start value. F of 2 is equal to 10. So the 2 goes in my n column. The 10 goes in my f of n column. Now, what tells me what we do mathematically down my table? What in here tells me mathematically that we're going to do down our table? Perfect. We're going to subtract 3 down our table. So 10 minus 3 is 7. 7 minus 3, anybody? Is 4. 4 minus 3, 1. And then my n column, the stuff on the n column side, well, that just goes 2, 3, 4, 5. So that back number, that f of 2 is equal to 10 or a sub 5 equals 1, that tells you how to begin on your table. Okay? Questions? Panic or concern about using a recursive formula to fill out a table? No? Okay. No extra credit for these two guys here, the ones that we didn't do for the review, but that 5-point extra credit for the height of the waist off the ground graph, that's where your extra credit will be.